Let's look into another experiment to understand our rate of change of momentum. The procedure is quite simple. Set up the experiment as shown in the figure or seen in the figure. So the figure is better over here. I have the same toy car attached to a spring balance, the same spring balance, and that in turn is attached to a thread, which in turn is attached to another weight. So this entire system is stable because of this weight over here actually. So when I lift it, things starts moving. So what are the two cases over here? Case 1, drop the mass, right, this mass, to a small height. Observe the velocity attained by the toy car. I'll explain what is that. Drop the mass to a greater height. Observe the velocity attained by the toy car. So the difference is small height and greater height. We're talking about something called as mass. So this is your mass, right, over here. This is dropped to a smaller height from here to here, while this is dropped from here till here to a greater height. If this is h1, this is h2. h1 is lesser than h2. Right? Now, you have to observe the velocity in each of this case. Please make an observation about the velocity. So what can we observe? What did you observe? The velocity attained by the toy car when the mass drops to a smaller height. Smaller height is dash greater than, less than, or equal to the velocity attained by the toy car when the mass dropped to a bigger height. Clearly it was lesser, is it not? So if this was v1 and this was v2, clearly v1 is less than v2. But why is it so? It's quite simple. Say you have a kid sitting in this toy car system, not this, but a kid's toy car, and you guys are pushing. If you push for a smaller duration, say it will go to a certain speed and it will attain certain speed and it will move for a certain distance. If you apply for more time with the same amount of force, if you apply for more time, say in place of say 2 seconds, say you apply for 20 seconds, the car will reach a lot more speed than it would have in the first case. Does that make sense? The speed attained by the car in the second case is a lot more compared to the first case. I hope it made sense, right? In the same way here, because the height was less, the car got pulled for a certain length, only this much of length. While in the second case, the car got pulled for a longer length, means more time. And so it attained more velocity, and that's why we saw the velocity difference. So what is our conclusion? Conclusion is this. The change of momentum, that is change of mass, if not velocity, in this case mass is fixed, so change of velocity of an object is not only determined by the magnitude of force. It's not only the force that is dependent on, but also the time during which the force is exerted. Right? Larger the time, more time you apply a force, more the velocity the object attains. That makes sense, is it not? Yes, the magnitude of force is also dependent. If you have a magnitude of force which is not the same, then we can't talk about it. But we are talking about a constant force because the setup is same. But the duration to which the force were applied were different. Is it not? And so we can conclude that change of momentum of an object is dependent on the time factor as well. Okay, so that is your conclusion. So please pause, make your own statement, own paragraph, own writing. Draw, write in your language, whatever you're comfortable with. Language is not an issue. What you have to do is you need to understand and you should be able to recall if you read your notes. So this is what I want from you guys. So please pause and have a look.